Hello, and welcome to our brief overview of NComm's Ethernet OAM software architecture. Operations Administration and Maintenance, or OAM, used to be the province of Carrier Wide Area Network Technology. Things have changed. Ethernet is now being deployed in almost every area of the network. As it increasingly finds itself in applications formerly filled by WAN technologies, the lack of OAM capabilities has become a challenge. To meet this challenge, new standards are being implemented to allow carriers to employ this LAN technology while maintaining the traditional monitoring, problem isolation, and diagnostic tools required for geographically dispersed networks. NComm's Ethernet OAM source code puts market-critical Ethernet OAM functionality within the reach of every equipment manufacturer. Let's go through the structure and function of the Ethernet OAM code. Ethernet OAM hooks into the Ethernet stack with protocol handlers to receive and send messages. Depending on your requirements, there may be one protocol handler for 802.1ag and Y.1731, and one for 802.3ah. The protocol handlers deliver and receive packets from the Ethernet OAM modules. The NComm Ethernet OAM software will conform to the relevant portions of each standard and include functions as specified by the standards. 3 modules are currently available. The IEEE 802.1ag module provides connectivity fault management. This standard verifies end-to-end connectivity, and it uses 3 tools. The continuity check detects a loss of continuity between 2 MEPs or maintenance entity group endpoints in a MEG, maintenance entity group. This check is useful for fault management, performance monitoring, and protection switching. The unicast loopback is used to verify the bidirectional connectivity between a MEP, a MIP or maintenance entity group intermediate point, or a peer MEP, or to perform in-service or out-of-service tests between pairs of MEPs. The Ethernet link trace is used for adjacent relation retrieval and fault localization. In fault localization, the difference between the expected and retrieved series of MAC addresses provides information about the location of the fault. ITU Y.1731 provides OAM functions and mechanisms for Ethernet-based networks, including alarms and performance monitoring. Its primary purpose is to verify the quality of the connectivity. Like 802.1ag, it employs the continuity check, unicast loopbacks, and Ethernet link trace. In addition, the Y.1731 adds alarms and performance monitoring functions. The Alarm Indication Signal, or AIS, is used to handle issues in the network. NComm's Ethernet OAM code will initiate the transmission of AIS in the presence of certain defect conditions and will take the appropriate actions on its reception. Transmission will be stopped and the AIS state cleared following the nominal integration periods. Remote Defect Indication, or RDI, is used both for fault management and performance monitoring. RDI can be used only when the continuity check function is enabled. RDI is transmitted on the detection of a defect and cleared when the defect clears. The Ethernet locked signal is used to indicate that data traffic is intentionally being interrupted for administrative purposes like testing. The OAM code handles both the transmission and reception of this signal with the appropriate integration periods. The Ethernet test signal function is used to perform one-way in-service and out-of-service diagnostic tests. OAM functions for performance monitoring are currently only defined for point-to-point connections. The 4 parameters available for trending are frame loss ratio, frame delay variation, and throughput. As appropriate, these measurements are collected for single and dual end loss and one- and two-way delay. Further, NComm's Y.1731 software includes vendor-specific OAM, which will be accommodated from a communications point of view. It also includes the Ethernet Maintenance Communication Channel, or MCC, and is used as a communication channel between pairs of MEPs. This Ethernet OAM module provides general access to the MCC. The third module available today is IEEE 802.3 Clause 57, formerly referred to as IEEE 802.3AH. It is used at the link level with the primary purpose to verify connectivity point to point. Loopbacks are remote data layer frame level loopbacks. During these loopbacks, both local and remote DTE can be queried for comparison. Remote failure indication, or RDI, is provided as an alert to appear that the receive path of the local DTE is non-operational. Also provided are standard compliant counters, timers, and state machines, including OAM discovery process, transmit, multiplexer, and parser. Variable processing requests for MIB information from the remote end, as well as requests by and the return of MIB variables as required, is also accommodated. Now, how do you integrate your applications with NComm's Ethernet OAM code? A well-defined API is employed for fast first-time integration and ease of reuse, and it is used to interface your applications to the Ethernet modules. In Linux environments, a translation layer is used across from the user to kernel space. This translation layer allows all coding to the API to be in C code. There are only 3 function codes used to communicate with the software. First is the control call. This call actually changes and sets parameters within the software. The second is the poll call. The poll call asks for information, does not change anything. And the callback is for when something important is happening within the NComm software that the layer above needs to know about. A sample demo application provides functionality very quickly. This sample also functions as a guide for integration of the Ethernet OAM software API into the upper management or control systems of your choice. As all NComm OAM software, Ethernet OAM is architected to be hardware and operating system independent. NComm's Ethernet OAM software is offered with OS drivers for Linux, both 2.4 and 2.6 in various versions, VxWorks, Nucleus Plus, and OSE. A driver template and guide is also provided to make the development of any OS-compatible driver protocol handler quick and straightforward. NComm's Ethernet OAM software is supplied as ANSI source code. User manuals, implementation training, and technical support are also included with each license. Please feel free to give us a call. We can discuss your project, the exact fit of our software, and don't forget to ask for your free copy of NComm's Communication Developers Handbook, a free resource that I think you'll find interesting. We thank you. Have a great day.